In this video, we're going to learn how to combine inductors together that are in series or parallel. The main rule to remember is that the formulas for combining inductors are the same as the formulas for combining resistors. So in this case here, where we have a bunch of inductors that are in series, you can combine them all together and your equivalent inductance will just be the sum of them, just like it would have been for a resistor. There's nothing special about it, just follow the same rule. On the other hand, when your inductors are in parallel, it is again the same rule as parallel resistors. It's unfortunately more complicated than the series rule. And that is that if you add up the reciprocals of the individual inductances and you take the reciprocal of that, then you will get the equivalent inductance. It also has the shortcut, whereas if you only have two resistors in parallel, then you can go ahead and do L1 times L2 over L1 plus L2. Now, because these have the same rules for series and parallel that a resistor does, then mathematically you could also do the exact same Y delta rules for inductors that were in the Y delta shapes. That's something I personally am never going to make you do, but it could work. I'm pointing that out here. Now let's go ahead and turn our attention to this example here. We have 40 and 20 in series. That's going to make it into a 60 millihenry one. And then we have a 60 millihenry in parallel with a 30. That is going to be, let's see, 60 times 30 over 90. That is going to give us a 20 millihenry inductor. So let's go ahead and combine things here. 20 millihenry, 40 millihenry, 100 millihenry, and then we already did the remaining parts there is 20. And then 120 in series makes 120. And if I do the 120 in parallel with 40, we are going to get 30 millihenries there. So continue redrawing the circuit here. And then to finish this up here, the 30 and the 20 in series make 50, and then 50 in parallel with 50 is going to make 25. And we found our equivalent inductance. So again, just like a resistor network, but we have henries instead of ohms here.